Sirs, what's up and welcome back to another video. Today we're going to be talking about chain rule differentiation. Okay, what just happened there? Okay, let's just go back. Chain rule differentiation. Bam. Alright, so what does that mean? Well, this is what it means. So let's say you have a function which is h of x is equal to f of g of x, right? Which is basically bracket g of x. That means if your f of x is 3x, right, and your g of x is, let's say, 6y, f of g of x would be 3, and then instead of x, you plug in the 6y. So 3, 6y, which is 18y. But that's just a brief example to show you what exactly this means, right? So what have this f of g of x. How do you define h of x? Because h of x is f of g of x. So how do you differentiate this? Because this is no longer one singular variable. It's two. So how would you differentiate this? Well, that's where the chain rule comes in. So the chain rule states that if you want to find the differentiated version of h of x, you have to do f prime of g of x, right? So f prime of g of x. So you write your f prime on the outside and multiply it inside of your g of x, and then times it by the differentiated version of your g prime of x. So just saying, you keep this the same, but you write f prime of x, and then g of x, you keep the same inside the brackets, and then you multiply it by g prime of x. Now, there's another way of writing this. It's written like this. It's a little bit complicated like this, but if this helps you understand it, please do pause the video, read it, and take some notes because we're going to be doing some questions now. So this is the question that you're given. Now you have a couple of seconds. Please do try to solve it before I solve it. Okay. Hopefully you pause the video and had a go. Now, if you haven't, please pause the video and try again. And if not, then let's get started. Let's get started solving. So to find out this, the differentiated version, dy of dx is basically differentiated y. It's y prime is dy of dx. Not to confuse you or anything. So to find this out, what do you have to do? Well, first you have to class it. So you have a traditional f of g of x approach given. So your fx is cos, right? Cosine, cosine, while your g of x is equal to x squared, x to the power 5 minus 4. These are your two variables given, right? So now let's try to find the f prime and g prime, because we're going to need them both according to our equation here. We need f prime in this case, and then g prime over here. So to find this out, we do f prime of x. So this is a normal variable. Cosine has a set differentiated form. So cosine differentiated, you have to memorize these, but cosine differentiated is negative sine of x. Let me put cosine of x. Yeah, so cosine differentiated is negative sine of x. The same way negative sine of x integrated sine x. And then sine x differentiated would be cos x. You have to memorize these differentiated versions. You can't solve them to figure them out, but you have to memorize the differentiations of every single trigonometric function. I know it seems long, but through repetition, it will get lodged in your head. Trust me, it got lodged in mine, and mine was a long time ago, and I still remember. And then differentiate version of x to the power of 5 minus 4, and this is where we apply basic differentiation. So we know that x to the power of 5, we're differentiating to x, so that means that this one is a constant. This 4 is a constant. That means it doesn't have the variable x. That means that the constant, whenever differentiated, always goes to 0. So you have x to the power of 5 differentiated. So x to the power of 5, applying our differentiation law, would be 5x to the power of 4, and then the constant differentiated would just be 0. So it's just 5x to the power of 4 minus 0. So now that you have of these, you have f prime and g prime, right? You have g prime of x, f prime of x. Yes, you have both of these variables now. Now we can apply our rule even further. So it says here the f prime of x and included g prime of x is in f prime of x. So that means we have our f prime of x now, which is negative sine x. So we just write it as negative sine x, negative sine, bracket, inside we put our g prime of g of x. So our g of x is still x to the power of 5 minus 4. So x to the power of 5 minus 4, right? And then it says here to multiply by the differentiated version of g of x. So g prime of x is 5x to the power of 4. So this times 5x to the power of 4. And now we can simplify this to write it as a negative 5x to the power of 4 sine x to the power of 5 minus 4. Bam. You apply the chain rule. So once again, it wasn't anything complicated. It's very simple once you look at it, once you understand it. I know I wrote it a little bit like complicated, but all you have to do is classify your f of x and your g of x. Once you do that, find out the differentiated version of f prime of f of x and of g of x. And if you can proceed from there, even then, some of the questions aren't going to get much harder than this. This is traditionally a harder question in general. But if you can figure it out from there, you'll still get some marks, one mark for differentiating it in general. So please do just do this in the exam. Now, for your homework, I have set one more question, very, very similar question to the one we did. So please do try this, right? It's a little bit different from what we've done before, but please do try this and give it a go, give it a go. And the marks scheme next page. So thank you very much for watching today's video. I hope you've understood everything that I've explained. If you haven't, please do comment down below in the comment section if there's anything you want me to expand on or talk about more in general. I will be doing more videos on differentiation, so please do let me know soon. Thank you so much. Take care and have a good day. Okay, signing off.